Now, what I'd like to do is have you, you know, put the material that you get and even stuff that you get and print off, put in your notebook, but put it in a format that you can find it, okay? Because I would like to be able to refer back to things like that and have you look it up in your notebook. So you got an extra reminder sheet to remind you about what you should bring. Everybody got that? Okay. Sharing computers is not legal unless there's somebody by you that needs to look. But you, the only person that has told me that they do not have a laptop computer is one person. So I expect you don't have it?
No, I have a desktop.
Well, bring it in. Okay, yes. Okay, well let's all try and get one. And the person that has told me they don't have one, I'll try and see if I can find a spare for them. Because, you know, you can get them, I think, pretty cheap now down at the ones down at Walmart that are $500 are really very, very capable computers. But you might, you know, need to, you know, go dining and dancing, and you need that $500 for something else, right? So, but I want to make sure everybody has it. This is really, really important because this is where you're going to start bringing material in and storing it. Get a backup system. It's really cheap now to get a external backup drive that you can back your files up and do that. I have files on my computer that are clear back in the mid-90s, and every time I get a computer, I've got to upgrade the disk on it a little bit. But it's really important. How else can you, all the material that you collect, how else can you have access to it in the future? So, okay, all those that have computers, go to Google. Pardon? Your Wi-Fi's not working. Okay. If you don't have a computer, invite somebody to get between you.
I don't have Wi-Fi.
Okay. So share your resources for today. Okay. All right, so you've got one between you two. You can see hers. We got some coupling here. Yeah, I'm gonna fall down. I'm just gonna go plop right on the floor. Okay, Chris, why don't we get? Well, can you see there? Okay, all right. Everybody can see there. Okay, all right. What I want you to do is to Google CubeSat. Oh man, what a TA, I'll tell you. You got to buy chocolate candy bars for him now. Okay, and click on images. How many's got CubeSats on images? Okay, all right. How many did it find when you did that? How many, let's see, let's go back to the web here. And let's go down here, well, no, right here. And just see how many it found, how many references to CubeSats. That isn't what I wanted, but how much was there? 376,000 references to CubeSat. And CubeSat hasn't even flown yet. Oh yes, CubeSat has, I'm sorry. Well, I want to get to CubeSat here. We'll just go to CubeSat. Well, I don't want to go to that. Okay, so 376,000 hits that it got on that. And let me just go to some of these and look at them. Here's the CubeSat launch initiative. Okay, let's see. These are showing all of the selectees on the map that apparently are what? They're selected to data come from 25 states. You know, and these locations are depicted below. But the thing I'm trying to point out to you, there is a lot of activity. Let's see, let's go up and, come on, get up there. Go up and click on images. Get back to images. Okay, so the images can show you here some of the different satellites. Are they all the same? What's different about them? Yeah, there's a difference about them, but this is essentially the standard. The standard says I have 10 centimeters from this corner to this corner, 10 centimeters from here to here, and I have 10 centimeters from this edge down to that edge, and I have 7.5 millimeters on these little things sticking out, and they're called feet. And what that is when it's in the launcher, and up here shows you some different sizes of them. When it's in the launcher, if you have two of them together in the launcher, this jack-in-the-box thing, then what you got is you don't want them to really touch each other with the surfaces that might have solar cells on. So it's a way to keep the satellites apart. And then what they've also designed is, you see this little silver thing up here, that's a place where they have a little indent ball. So when you push them together, it pushes that ball down. There's a spring behind it. And so when it comes out of the launcher, you can see there's, let's say there's 3 of them in there. So this guy comes out and that little spring pushes this guy away, and then they come out and the next 2 get separated. Why do you think they want to get them separated?
They don't collide.
That's one reason. One of the other reasons is a lot of them have magnets in them. And they put magnets in it. If you have a magnet in a satellite and it's flying up in space, what will the magnet do to the orientation of the satellite? It makes it follow the orientation of the magnetic lines. So it's passively magnetically stabilized. Now, what happens if you have 2 little magnets and you try to push them together and you have a north to a north? It pushes them apart, right? What happens if you have 2 little magnets, north, south, south, north? North here, south there. What happens to them? They click together, right? That's exactly one of the reasons that they want to push them apart. And it just so happened recently, there were some satellites got launched, and they couldn't figure out why these satellites had exactly the same ephemeris, and the ephemeris are numbers that are calculated and put into formulas to tell you where the satellite at. So if they keep, you know, generally when they get launched out, they separate over time, okay? These 2 got launched out, and they didn't separate at all. They were stuck together. So, you know, that's another lesson about that. So one of the things you got to do is simple little things like, well, if somebody would have told me that they would have not separated, I would have never believed them. Because it seems to me like when that pusher foot pushes those 3 CubeSats out of that launcher, wouldn't the first one actually, because the spring tension was higher, wouldn't maybe it have more velocity than the second one? The spring tension's a little less. And then the third, the spring tension's a little less. What do you think? Do you think they would separate? When they come out, they got different pushes on them. The first test that they did is they went up on the microgravity airplane, you know, the one that does all these ups and downs. And they launched them, and them suckers come out, just stuck right together. That was before they put those little pusher feet in there. But they stayed right together, and I would have not thought that. You know, what's your, you know, you think about things. What if you've got a slick table and you got a hockey puck on it and you push them? Will they go across the table all the way stuck together? My feeling is they wouldn't. They wouldn't. Because you might have maybe more or less friction with each of these. They'd be different. So anyway, that's some of the things that went on. So if you want to look at CubeSats or pocket cubes, you know, there's plenty of stuff on the internet. So lots of information. Be sure and use it. Read up about it. How many people in here use Google Alerts? Anybody? Do you know what Google Alerts are? Google Alert is a program that Google has that you can specify a particular word, and every time it finds an article or something with that word in, it'll send you an email and tell you what the article is. Let's see. Let me take a quick look here and see if I've got anything here. Here's one. I like to find out what Elon Musk is doing. So all I've done, see if I can get down to the bottom here, is I've created one of these, and let me just show you what my list looks like. This is my list. You know, I'm a little narcissistic because I put my own name in there. But these are just some of the names. There's CubeSat. KYSat is Kentucky Sat. Matchbook satellites. Nano racks. I've got all these things in there. And when I get a message, I can go look at the news. And probably some of you have things that look at the news. For example, who's Elon Musk? Oh, have you ever heard of the Tesla car? It is absolutely the coolest car you can get these days. Elon Musk is from South Africa, and he did not originate Tesla Motors, but he came into it fairly early and eventually become the president of the company. And Tesla Motors is, to me, is setting the standard for what cars should be in the future. Although right now they're a little bit more expensive, and I cannot afford a $100,000 car, and that's all it costs. You know, oh, he's got cheaper models. They're down to about 75 now. So, but anyway, they're real. Why is the Tesla so unique?
One of the world's first electric cars.
Completely electric, right? No hybrid, no motor in it. It's completely electric.
It's a fully sized sedan.
Yeah, and does it have very good acceleration performance?
It's also the highest. It has the highest safety rating of any vehicle they've ever reported.
Right, and go look at Tesla, and it's very interesting. You know, how do you charge your Tesla? Well, one of the ways that they charge it is, you know, you plug it into a charger at home or at night. But also what Elon Musk has done, if you have a Tesla and he is setting up charging stations around the country, how much does it cost you to go into his station to get charged, your car charged? Nothing. You go in. If you always go to his station, how much is it going to cost you for transportation to drive a Tesla? Zero. You're getting it free. If you use it at home, of course, you're using a little electricity there. It has a range of about 200 miles. So what he's doing is he's arranging for these charging stations across the country. But when you go in and you say, well, I want to go into a charging station and get this thing charged, one of the things that they thought about initially, how long it's going to take to charge a car. You don't charge it in just a few minutes. So what they did to get around this problem is they have a station that changes the battery. You drive up over this, up on this kind of little platform. There's an automatic lift that comes up, disconnects your battery, takes it down. Here comes a fully charged battery up and installs it in your car. And what you pay for that is you pay about the approximate price you would pay to fill your car with gas. It's not twice as much or anything else. Pretty reasonable. How long do you think it takes to switch that battery?
30 seconds.
That's pretty optimistic. A little more.
About 5 minutes.
Minute and a half. 90 seconds. And they did a demonstration where they had another car pull up to the gas pump, and it was an equivalent car. It was a very expensive BMW, and they changed the battery on this thing, and the guy was still filling his car. And so what they did is they drove a second car up, and they put a battery in it. The guy's still filling his car, and he got done shortly after that. But they could change 2 batteries in 2 cars quicker than the guy could fill his car up with gas. So it's a real revolution. How much pollution do you think they get out of that? Should be pretty clean. Should be able to run it in your garage and listen to the radio, right? It's not going to asphyxiate you. So anyway, also Elon Musk is a guy that owns a company called SpaceX for space exploration. And he has, since 2002, he's developed a rocket called the Falcon. And the Falcon, he can fly the weight on that for, I think, probably like at least 25% of the cost of equivalent launchers. He has just built this thing from scratch. And I'll talk about him on and off. But anyway, it's pretty fun to watch what he's doing. How many of you ever heard of the Dragon capsule? Okay, what's the Dragon capsule?
It was their attempt at building a more affordable ship to send up to the ISS.
Right, yeah, it's a capsule like the astronauts used to use and like the Russians use, but right now it's just a cargo capsule. So they send it up on their rocket, disconnect it, and then it flies on its own, goes over and it gets docked with the space station. They take all of the supplies out of it, load the supplies they want to send down, back in it. It comes back down, a parachute pops out, and it lands on the water, okay? It's called the Dragon capsule. Now, when you go for a trip on an airplane, who has gone for a trip on an airplane recently? Probably all of you, right? Have you? No? Have you been on an airplane? Oh, it's the worst situation you'll ever run into, right? Oh man, you get crunched in the cattle car, and it takes you how long to get there? And there's a guy over here, and he's going, you know, and there's a lady over here, and she's going, beep, beep. So anyway, and then all the time you wait in the airport and everything else. One of the things Elon Musk is proposing to do is build what they call a hyperloop. It's a train that will go from the East Coast to the West Coast in what? 2 hours or something less than that, isn't it? Yeah. So watch this guy. Put a Google alert in. If you can't find Google alert, just Google alert, okay? And you'll find it. All right. So let me go on here because you know, I could talk about this all classes all the time, but I'm not sure that that's actually what you want. Also, if you look at pocket cubes, you'll find pocket cubes around. Okay. Here's some of the people that are working on pocket cubes. And did I show you the pocket cube yesterday? Okay, I want to make sure. All right. So what I want to do is to tell you about this. I don't know why Professor Malfris thinks yours is a special class. You are the first students that will have benches down in the high bay that you can work on. How many of you have been in the high bay where the clean room is? Did you get your benches when you first come here? No, a little bit. Anyway, we're going to take a tour next Thursday as part of our class here. And this is a place where you can go in, you can have projects, you can, and if you need access after hours, we've got badges. You got a badge? Where's your badge? On the back of your telephone. Okay. Let's see. Everybody got their cell phone out and shut off? I hope. Yeah, that looks good. Okay. you'll have a badge that'll allow you to get into the building and into that room 24 hours a day. You can go down there and study if you want. The only thing that we ask is that when you work on a project down there, if you're going to leave longer than to go to the restroom, clean it up, you know, clean the scrap parts up and throw them away. You don't have to put everything away. But I'll tell you one thing, if you have a messy bench, you never want to be down there when the university president does a walkthrough. He does not like messy. I don't know what his office looks like, but he does not like messy. You know, we have a gentleman just down the hall here, and if you look through his window, that might look messy to you, but to us, it looks like somebody's really working, and he is. So there's a difference between what certain people see as working, and you as future engineers, you can't work with just a pencil on your desk, can you? You know, you got to have your stuff spread out. How do you find it if it's not a foot deep on your desk, you know? If you file it, then you forget about it. So, okay, on the agenda, we've taken care of the conflicts. I want to talk to you just a little bit about some stuff in the lab. So I want to talk to you about Mechatronics. What is this Mechatronics? We talked about it a little bit before, but I'm just going to show you what we're going to go through in the lab, and you'll get some idea. You know, at first what we're going to do is just go through and give you some idea of what it's going to be like tomorrow in terms of why you want to take Mechatronics. And then there's an assignment, and the assignment is to look at the look at the things that we talk about. I've got a set of slides here that I can go through, and if I have time, I'll do that today. So that's assignment number 1, is really to see these slides, go through the slides, and just answer some questions. The second one, which hopefully we can get into this Friday, is the toolboxes, and we will provide for you a toolbox with probably maybe upwards of $150 worth of tools. This is on loan to you, but what we want to do is hand the tools out, and one of the things that you'll have, and I'll hand these out now. This is for the excuse me. That's for the first lab. This is for the second lab. And one of the things in the second lab, which, like I say, may be the first day, is to go through and mark down all of the tools in your toolbox. Now, one of the things that we're going to require is for you to go on the internet and find out where you can buy those tools and what the cost is. Because one of the very important things in the Mechatronics is if you want a particular part, how do you go find it? How do you get on the internet? Who are people to help you there? And later on, I'll give you a, let's see, I'll give you a sheet. Do you want to pass these out? I will give you a sheet that has a whole list of vendors on. There's people like, a company that I like a lot is called Jameco. There's an unknown company called Radio Shack. Ever been to Radio Shack? Actually, they have quite a bit of stuff. Here's some of the things that we're going to do in there. We're going to, you know, get through the toolbox, and then we're going to start working on how to use some of those things. We've got multimeters, we got proto boards. We're going to show you how to connect up things. We're going to show you how to solder, and then one of the things we're going to solder is that little jiggy that I passed out. And then what we want to do is you just go ahead and build it, but then we want to find out what it's all about. And then I want to build a little power supply board that you need. When we use the basic stamp kit, normally what you do is you put a 9-volt battery on it, but it gets expensive to keep putting 9-volt batteries on it. So what I've done is developed a little board that first I put on it a switch so you could turn it on and off. It didn't have one. And then I built a board that you can plug a 9-volt power supply that goes in the wall. But it turns out if you look at that 9-volt power supply, it's not 9 volts. It's about 10 to 14 volts. So you can't hook that power supply directly to your basic stamp kit. So we put a 9-volt regulator on it that regulates it from maybe 13 volts down and is always at 9. But there's other voltages we need for things, so we're going to put a 3.3 volt regulator on it and a 5 volt regulator. And so what you can do now, if you need a little power supply, you just take this off your basic stamp and plug it into the wall. It's got a switch on it, you turn it on, you got 3 voltages. So it's kind of a little exercise that I think is worthwhile to do and to have. And then what we'll do is you get your basic stamp kit, and this is a copy out of it of the different chapters. You're going to go through all of the chapters that are in that basic stamp, and it's got the components with it. It's got a good manual with it, but that's where you really start getting into things. And we're going to build a thing called a CubeSat that you can measure temperature with, and we fly it on a balloon. Then we're going to have an RC car. You take the RC car controller apart and you wire it up so it can work with your basic stamp. So you program your RC car that I think we showed you last time to do things with it. And then one of the things, if I can get it arranged, is to go to Hazard as a group and go through the session in the Challenger Center at Hazard they have over there on the space station. We want to also take you through some shop training. We have a small shop upstairs. Let's see. And then down here, here are some potential projects. One is using the basic stamp as a data logger. What you'd like is there's certain times you would like to have something that's just recording information for you, okay? So you could take the basic stamp and you could make it so it just fit in your pocket, and then, you know, walk around the campus for a day and then take the data out of it and look at it, plot it. What did it look, you know, what was the temperature? You know, you can see, well, here, you know, it's the winter, I went into a building and it sat there at room temperature, and then I went out of the building and it got cold, or if it's during the summer, it gets hot. So you want to record this. Then could we do other things with it? What if we could put a sensor on it that recorded carbon monoxide? Is carbon monoxide good? Where do you get carbon monoxide from? Cars. Do you think that the playgrounds at grade schools that are next to a freeway are healthy? But they have them, right? Why do they have them there? Why do they let those kids go out on that playground when it's probably dangerous to them? Because they don't know, right? Why can't we make a data logger that we can set around the playground, and we could record carbon monoxide levels for 24 hours at all of these different points and put it together in a graph, a 3D graph, so the height of the elements in the graph show the concentration of carbon monoxide, and the principal could sit there and go and look at it every 10 minutes, every 15 minutes. And do you think he'd find a time during the day when he probably should not let those kids out on the playground? Would you think so? Do you think that should be of interest to the school board? I think so. Would you like to have one in your house? How many of you have a carbon monoxide monitor in your house? Did you have one?
I don't think so.
Yeah, I think we used to have one in another house. I'm not sure that we got with it again. But how would you like to have this thing that you built set in your house and send off an alarm if the carbon monoxide got very high? Or could you look at it over a period of time? So there's lots and lots of things that you can do with it. And if you think about a satellite, it's the same sort of thing. Let's say you have a satellite that wants to take pictures of the Earth. So all that's doing is going over and snap, 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 recording data, right? Sends it down to you. You bring it up, you look at it, and decide what you want to do with it. So that's just an expensive data logger. So that's the kind of things we're going to do. Build an anemometer to measure a wind velocity. How would you do that? What's an anemometer? Right. Okay, you got to build one from scratch. How do you build it? Okay.
Little thing that like goes around like some magnets, like
right.
and then you see how fast
So a magnet. So you're going to have something that detects when a little magnet goes around every revolution, right?
Can't you do that?
Huh? Pardon?
Can't you do that?
You can. We'll show you how. It's a piece of cake. We can find all sorts of things to do that. Now, you can get it. What will you get when that magnet makes one turn? You'll get a pulse of some kind, right? Electronic pulse, right? Okay. Now, how do you determine what the wind velocity is? You got pulse, 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 pulse.
You figure out like how fast the wind's going, but like knowing how fast the wind's going first. And
Yeah.
see how fast the pulses are.
Okay.
And then that's like your base. And then how the wind's going any other time you can compare it to the base.
Sure, absolutely. Now you got your anemometer working. How do you give me something that gives me wind direction?
Like, they're shaped like chickens. And
Okay.
whichever way the wind's blowing, they're like flat on one side. So it's
Okay.
that way.
How are you going to tell me which way it's pointing?
I don't know.
Thing called a sensor. I will have a sensor on it. But you can do all of that. By the time you get through with this class, you can do that kind of stuff, because what we're going to do is give you the tools. Have you ever built a house?
Like a little Lego house.
A Lego house. Have you ever done any carpentry work?
Yes.
You have? Well, you know, if I give you a saw and a hammer, can you build me a house?
Not yet,
Not yet. Why?
because I still gotta get to understand electrical.
Well, first of all, you need more tools, right? Yeah, okay. So he doesn't have enough tools, so we got to get you the right tools. And what's that thing that they roll out and look at to know what the house is going to look like? The schematic? No. Plans, right? Okay. Don't you have to have some plans to know where you're going?
Yes.
Yeah, right. That's what you're going to get in here. Look. Here's the plans. Go build me a house. Is there a house plan in there?
No.
Oh, okay. But we're going to give you the tools. We're going to give you the tools. Do you guys have any ideas or any fun? Do you see anybody working on private projects down there? No. Will was one of them that got caught by the president, I think. But we're going to give you benches down there where, if you have to, we'll give you a little black sheet that you lay over it at night when you leave, you know, so they can't look under it. But that's what we're doing. We want to prepare you to do that sort of stuff. To me, the first time I programmed a computer, I was so amazed. I thought I was really smart, and the more I programmed, I realized how dumb I really was, because there's so many ways to do that. But anyway, that's what you're going to get in the lab. Do you like to build things? Ah, that's what we do. We build things here. We make things work, almost. Sometimes you have to fix them. And when you have something doesn't work, what do they say you have in it? There's this term about bugs. Ever heard of it? Oh, this thing's got bugs in it. What does a bug mean?
Error or malfunction.
That's right. It's an unanticipated response is a bug. Do you know where that come from?
Someone had a problem with their servers or whatever, and they couldn't figure out what it was. And they tried everything, and then they looked, and it was like a moth caught in there or something.
That's right. There was a lady that was working for the Navy, and they built one of these first computers that it was made out of relays, you know. Big room, all of these relays going clickety, 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 clack. And the relays are either on or off, so it's a digital sort of thing. And it quit working, and she got poking around. She actually found a moth or a bug of some kind in it, and so that's where it come from. It's a bug. Look it up on the internet. Can you? I'll tell you what. I'll give everybody in here 100% on the next homework that finds out who the lady was that found that. How are you going to find out? Google. Google's your savior. So, you know, next time you come in, you tell me what the lady's name was and a little bit about the story. All right. Okay, so this is just going through. We got some things that we want to make called ping-sats. Ping-sats will be on balloons. We want to make things called lake-sats. It's like a buoy that's measuring it. We want to do a river-sat. We'd like to throw a buoy in the Ohio River and monitors it goes through and over into the Mississippi and out into the Gulf. Would that be cool? Find out what's going on. What do you think's going on in those rivers? Fishing? Pollution, right. We could measure pollution. And you know, everybody says, you can't do that. And I say, why? Well, people are going to steal your boy. And I say, okay, we get GPS data that's sent back to us on radio from this. And what would we look for if we think somebody's stolen it?
It's no longer in the river.
Yeah, that's right. It's traveling outside in somebody's pickup, right? And away it goes. We'll find it, right? Unless they learn how to shut it off. But that's the challenge, you know. Could we make it like a little submarine? Could we make it go down and be about 4 feet under the water, and then periodically it comes up, solar cells charges the battery, and it goes down again? Well, that'd be cool. Yeah.
Would we be able to make it so that it could avoid objects, or if it hit them, it'd be tough enough to withstand like rocks and stuff at high speeds?
Well, it's, you know, if you just put it in there, and even if it was underwater, I'm thinking about a piece of PVC plastic pipe, and that's pretty strong. And if it hits something or just at the velocity of the water, it would probably not hurt it. But if somebody run into it with a boat, it could. So, you know, I think people run into logs and other things in the river, don't they? Yeah. So, you know, the other thing to think about, how smart can you make it? You can have, if you look around, you can find bilge pumps for boats. They pump the water out when water leaks in, okay? So you got a couple of little bilge pumps on it, okay? And all of a sudden it picks up a vibration in the water, and the little motors can turn, and the thing that picks up the vibration can be directional. So it says, oh, there's somebody coming in a boat, ooh, or ooh, out of the road. So you could have it do that. You GPS, right? Computer, motors, all that stuff we know how to run. So it'd be good. Have you got something you want to do in your backyard? If you want to monitor rain or wind or temperature or when the cat comes in and out, anything like that? Have you got any real good ideas? We can make them. We can do them. Okay. Let me go on. So there's lots of good stuff here. We're going to have a lot of fun with this. The thing here on the cave run automatic temperature and oxygen measurements. Turns out my neighbor is the guy that takes care of the dam down here at Cave Run Lake. And I talked to him about some of the measurements and stuff they do. And they do a manual measurement now. They have this thing that they lower down in the water, and it measures temperature and it measures oxygen content. And what they do is have a couple of guys in a boat go out and they lower it down till it hits the bottom. Then they start reeling it up, and they have markers on the cable of where what the depth level is. And so they get data out of this thing as a function of depth and temperature and oxygen. Why can't we build something that does that automatically? Why can't we make a buoy that's out there that has a little thing on it, and at 10 o'clock every day it starts up and it lowers this thing on a cable, okay? It can determine when it gets to the bottom because the cable's going to go slack, right? Okay, I can determine that. And then if I start reeling it up, I can determine what the depth is by having this thing run over a little pulley that's a counter, all right? And then when it gets up to the top, you can extract the data out of this thing, and you can send it wirelessly to the dam manager's office that picks it up and gives him a graph right on his computer. Would that be cool? That'd be fun, I think. So there's all kinds of things we can. The only thing that's wrong with this class is we don't have enough time. Will you drop all your other classes so we can just play in the lab? Wouldn't that be fun? Okay. Okay. So this is introduction to space systems, and you know what's going on there. Well, I wanted to give you a little bit about what's happening in the course. What is the course all about? And we've talked about that so far. We've talked about how you'll benefit from it. Do you think what we talked about could be of benefit to you? You bet. One of the things we talked about is this Innovation and Realization Center, We would like to give you the opportunity to come up with something that you think other people would need, and let's see if it's marketable. If it's marketable, we'll see if we can help you start a company. So, you know, is the course only for those interested in working in space? I can definitely tell you that the education that you get in this course is not only for space. There's lots of other things you can do, especially with a background in mechatronics. So what's going on in space today? Okay, so what happens in this course? You got a textbook, and we will use it just for general reading, and I'll try and give you the assignments to read in it. You don't need to worry about the problems in it. We'll have separate problems for you. So read the assigned material. Look on the internet for things that you can see, and review the slides that we go through. Okay, and these lectures obviously will be recorded, and they'll be on the internet, so you can go back and look at them. And we will have periodic tests to make sure that you're getting as much material as you need. So you put all of that together, and we'll have lab and lectures, learning mechatronics. The lab classes will be building things. You can see there in the second picture right here, this guy's built a little jiggy, and he's dressed it up. There's a little eye on it, and there's some ears and horns and other kinds of things. And we like to put them together. If you look in the case outside there, there are a couple that were built there that I stole from a couple of young ladies. But you got to show them the best, right? Okay. So again, here's some things that are kind of outside of the book. We're going to give you reference to these things. There's a lot of awfully good material out there that you're going to have to look at on your own. One of the things that you need to get out of this class or any class is your ability to go study it without having to have a formal class like this. The better you can study, the better you can absorb. You know, your boss comes to you and he says, well, listen, I would like you to do a finite element analysis on this satellite. And you said, but boss, I only did work on the electronics. And the boss says, oh. So he goes over here and he says, can you do a finite element analysis? Yes, that's one of those extra classes I took at Moorhead. Hey, you get a raise, right? Was that what you'd like? Yeah. All right. Here's a little thing that we just build with some switches and some LEDs. We use a lot of LEDs. There's the little jiggy. The guy put his picture on it. And we fly CubeSats on balloons and measure temperature with altitude. We got high flying, we call near space balloons that go up to over 100,000 feet. So we put experiments on those. And what you're seeing there is that line is the edge of the Earth. How thick is the atmosphere there? Not very thick, is it? We don't have much atmosphere over compared to the size of the Earth. Okay, here's some things about pocket cubes and CubeSats. You're going to learn new language. Have you ever heard of geek? Orbits, eclipses, drag, space radiation, atomic oxygen, all kinds of things. This is what you're going to learn. What is space used for? How does it affect our lives? What's the space environment like around us? Is it a nice place to go and just float around? Oh, it's nasty. Why? What makes it nasty? Space radiation. Where's that come from? The sun and the cosmos. There's all kinds of nasty stuff out there. We're going to talk about orbits, orbits, and orbits. Space systems engineering, mechatronics, building things with mechatronics, double use of terms. Sometimes you'll talk satellites, sometimes you'll talk about spacecraft, sometimes you'll talk about bus. Bus is just part of the thing that supports the payload. So, we're working on satellites here, and we actually are associated with a lot of other things out of here. Here's some of the things I talked about: the Dragon, the Falcon, the HTV is the capsule that some of the other people, I think it's the Japanese, use to take things to the space station. How do you benefit from things? We're going to go into that. You get to work as a team. There are many skills that you've already learned by interdisciplinary work, and that's part of this. Work over a lot of different things. Gaining hands-on skills by building things in the lab and in the shop. Your skills being presenter. One of the things that you as an engineer have to do is to be able to present your information to your customers and your associates. Apply new computer skills. Did you get an offer for a new computer skill today? Yeah, that's pretty good. Okay, is this course only for those interested in space? No, it's valuable for lots of things. Science or math teacher, medicine, physics, astronomy, astrophysics, finance. Okay, so let's, all right. So what's happening in space today? How many of you know about the Curiosity rover? Pretty cool. About, what, a year ago it landed on Mars? Has it found anything significant? Yeah, right. It's a very interesting the way it landed, and if you go to this site, you'll be able to see a video on it. Okay. What's going on in space today? SpaceX, I talked a little bit about that. New company. They're doing great things. A guy named Elon Musk. How many have heard of PayPal? Okay, Elon Musk started PayPal, and he sold PayPal. Made him a billionaire. So he had to do something with his money. So he decided to spend it on space. Okay, this is Elon Musk, okay. He's, I think, about 40 years old. He's from Australia. Started PayPal. Made lots of bucks off of it. One of the things he does is he goes out and wrecks cars. I think that's a Ferrari, isn't it? So he wanted to do things in space, and he went to the Russians, and he tried to buy a rocket from the Russians, and the Russians thought he was a little bit cuckoo, so they wouldn't sell him a rocket. But he wanted to go to the Russians, and this is what the Russians thought of him. You know, if you go over and you act like that, I'm sure that they won't sell you a rocket, right? They don't know where it's going. So anyway, look up Elon Musk, look up Tesla, look up SpaceX. Lots of good stuff there. Someday you might want to go to work for Elon. There's a Tesla car, $100,000. Okay, there's the Dragon capsule. Going up to the space station, re-entering. Come down on a parachute. Okay, go through these slides and take a look at them. Pretty interesting. Now, I'll tell you next time, but I want you to come back and tell me what are the ideas that Elon Musk has that's going to reduce the cost of launch going to space. What? Shh. She said reusable rocket. We won't tell anybody else, will we? Okay. Thanks very much. See you tomorrow.